All right, let's look at truth tables now. For a lot of you, this will be the absolute worst thing we have to learn this year. But the good thing is we're going to learn it this section. We're going to practice it on our homework. We're going to have a test question on it, and then we'll be done. Like, we don't have to do more with truth tables. So just bear the brunt with it and get through it. All right, so what is a truth table? A truth table is a table that breaks down the truth value for all possible values that a function can attain. Okay, that means it tells whether or not the statement is true or false, regardless of whether the hypothesis is true or false, or whether the conclusion is true or false. So truth value, like I just said, whether the conditional statement is true or false. And we would find its truth value by drawing a truth table. All right, so let's draw our first truth table. Now, truth tables are considered politician statements a lot of the time because the only time a statement is considered false is when the hypothesis is true, but the conclusion is false. That's the only time a statement is considered false. Every other time it's true. So even if the hypothesis is false, we're considering the statement is true. That's why it's considered politician statement, is because, you know, they have a tendency to stretch the truth. Well, kind of the same thing. All right, so what we're going to do is we're going to make this table. So we're going to make, it looks kind of like a T-chart, okay? We're going to start it where it looks like this for now, okay? And we're going to have P in one column, and we're going to have Q in the other. Okay, now remember P and Q is the hypothesis and the conclusion. All right, now we want all possible scenarios. So maybe P is true. And if P is true, Q can either be true, or P can be true and Q can be false. Okay, so if P is true, Q has to either be true or false. There's no other thing. And then if P is false, Q can either be true, or if P is false, Q can be false. So this is all scenarios. So there's only 4 scenarios with P and Q. Either P is true or false, or Q is true and false. And together, either we have true, 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 false, false, true, false, false. There's no other combination. All right. So we are going to go now to the conditional statement. If P, then Q. Okay, notice P is my hypothesis, and Q is my conclusion. Okay, so this is my hypothesis, this is my conclusion. Now let's go back to here. The only time this conditional statement is false is when the hypothesis is true and the conclusion is false. Okay, so the hypothesis is true and the conclusion is false. So let's look at this. Where is the hypothesis true? Remember, the P is the hypothesis. Where is the hypothesis true? So it's either here or here. And the conclusion is false. Well, here's the conclusion false. So this second statement is false. The rest of them are true. And that's all that truth table looks like. All right, now that we have done the truth table for the conditional statement, which is right here, it's the same thing we just wrote down, let's do it for the converse, inverse, and contrapositive. Okay, so let's do it for the converse first. And remember, the converse is just if Q, then P. Okay, so we're going to start this the same way. We start all of them the same way. We have a column for P and a column for Q. And then we're going to go if Q, then P. Okay, now P can either be true or false and Q can be true and false. So we're going to start this. Guys, these 2 columns will be the same for any truth table we do. So true, true, false, false, true, false, true, false. All right, now notice that in this statement, Q is the hypothesis. So this is the hypothesis. And P is the conclusion. So P is the conclusion. Okay, so once again, the only time a statement is false is when the hypothesis is true and the conclusion is false. If you have this, it's a false statement. Okay, so I'm going to look here. Do we have a hypothesis is true? Remember, this Q is the hypothesis. So where are we true here, but false here? So we want true here, false here, and that would be a false statement. So we're true here and here, and then we're false here and here. So this would be a false statement. Okay, the others are true. So that would be the truth table for the converse. Okay, let's do the truth table for the inverse. Now remember, inverse is not P, then not Q. Okay, this is a little more in depth, but it's the same concept. So we're still going to start with P and with Q. So we're still going to start true, true, false, false, true, false, true, false. All right, now notice on the inverse, we have not P and not Q, right? That's what these things are. Okay, so we need to get columns for not P and not Q before we can get if not P, then not Q. Okay, now we have to look at P in order to determine what our not P is. Okay, so guys, if P is not true, what does it have to be? It has to be false. And if P is not true, it has to be false. But if P is not false, then it has to be true. And if P is not false, then it has to be true. Okay, same thing for not Q. So we're going to look at Q and we're going to say, all right, well, if Q is true, not Q has to be false. And if Q is false, not Q has to be true. It's just going to be the opposite. True, that goes to false, and then the false goes to true. Okay, now if I look at this inverse, I don't need the not P and not Q, and this is a me thing, you don't have to, but I'm just going to X these two columns out so I don't use them. I'm done with those. After I get my not P and not P and not Q, I'm done with that. So now I can go ahead and look to see what is not P implies not Q. Okay, same thing. So we have our not P is our hypothesis. So this is our hypothesis. And our not Q is our conclusion. So once again, when we have a hypothesis that's true, so here's our hypothesis, so we have a true here and a true here, and a conclusion that's false, here's my conclusion, I have a false here and a false here. When both of those things happen, I have a false statement. So right here, this is my false statement. The other two, we're stretching it a little like politicians, they're true. All right, all we're left now to do is the contrapositive. So remember the contrapositive, is not Q implies not P. So I want you to try first to do this truth table on your own, and then we'll go over it. All right, we're going to start this truth table just the same as we did last time. So our P is true, true, false, false. Q is false, or true, false, true, false. Every combination there is. So notice our contrapositive, we need a not Q as our hypothesis and our not P as our conclusion. So it doesn't really matter what order you put these through. I like to try to put them in this order here. So I'm going to do my not Q first, and then I can do my not P second. All right, so not Q, remember, it's just the opposite of Q. Okay, we're going to flop these. So if Q is true, false, not Q has to be false, true, false, true. Okay, and then we're going to flop these two. So if P is true, true, false, then not P has to be its opposite, which is false, false, true, true. Okay, so once again, my not Q is my hypothesis. So this is my hypothesis. And my not P is my conclusion, because remember, the hypothesis always comes before the conclusion. So if I'm doing my not Q implies not P, remember, this statement is only false when my hypothesis is true. So my hypothesis is true here and here. And the conclusion is false. So my conclusion is false here and here. So the only statement that both of those happen is this one here. So this is a false statement. Every other statement is true. All right, so equivalent statements would be when two statements have the same values determined by its truth table. Okay, so if we compare the four truth tables on our previous slide, you should notice that we have pairs here. Okay, so notice that the contrapositive and the conditional table, oops, can't spell, both have the same truth table. Okay, so we have true, false, true, true, and true, false, true, true. And then the inverse and converse, let's scroll up a little bit here. Both have true, true, false, true, and true, true, false, true. So the inverse and converse are equivalent statements. So that means that anytime a conditional statement is true, the contrapositive has to also be true. Or if the conditional statement is false, the contrapositive has to be false. And the same is true for inverse and converse. Now, all four can be true and all four can be false. It's just that these two have to match with the truth value, and these two have to match with the truth value at all times.